In our previous video, we looked at atomic theory. You are going to see the link to that video at the start of this video. We looked at atomic theory and we saw the contribution of various scientists to atomic theory. In this video, we are going to look at atomic structure and we are going to discuss isotopy also. The structure of an atom is such that an atom has a central nucleus, a nucleus in the center, and electrons are located in orbitals. So the region of maximum probability of locating an electron is called orbitals. So we have nucleus at the center and electron revolving around the nucleus in their orbitals. So nucleus contains elementary particles which are proton and neutron. So in the nucleus we have proton and neutron. Understand that association of proton and neutron is called nucleon. So nucleon is the collective name for proton and neutron because they are both contained in the nucleus. Then electrons are located in the orbital. So now, for an atom or for an element, the general representation for representing an atom or an element is commonly written this way. So if we have an element or an atom X, you are going to see that we always have a superscript, maybe A, and a subscript, maybe Z. You should understand what this A and Z stand for. A is commonly referred to as mass number of the atom. Then Z is commonly referred to as the atomic number of the atom. Also note that atomic number has another name. Atomic number is the same thing as the proton number. So atomic number equals proton number. So you can say that Z is atomic number or proton number. You must also know that mass number of an atom is equal to the number of proton it contains, number of proton, plus the number of neutron in the nucleus. So the mass number is almost equivalent to the whole mass of the atom, and that is equal to the sum of proton and the sum of neutron it contains. You must know that information. Then again, you have to know that for a neutral atom, for every neutral atom, number of proton must equal to number of electron. So if an atom is neutral, that is, it's not carrying any charge, the number of proton and number of electron must be the same because proton is positively charged, electron is also negatively charged. So when you have equal number of positive and negative charge, then the atom is said to be neutral. All right, so those are the basic things that you must know about the structure of an atom. Now let's consider this question to see or to buttress what we have just mentioned. This question says that an element X has 127 neutrons and 82 electrons. So number of neutron is 127 and number of electron is equal to 82. Its atomic number is, so we have to look for atomic number. I said earlier that another name for atomic number is proton number. So invariably we are looking for the proton number or the number of proton. Since we have that this atom is neutral because we are not told that it has a charge, so we are going to assume that it's neutral. So if it is neutral, number of proton and number of electron must be the same. So if number of electron is 82, number of proton must also equal to 82, which means that the atomic number is equal to 82, and the correct option will be option D. So if we have a question that says that what is the neutron number of this atom? So oxygen 16, 8, 2 minus. So we are looking for the neutron number. We know that mass number is neutron number plus proton number. The mass number is the superscript, so 16 is equal to, we don't know the neutron number, plus but the proton number is the subscript. So the proton number is 8, which means that the neutron number is going to be 16 minus 8, and 16 minus 8 is equal to 8. So this atom has 8 neutrons. But what if it is the number of electrons we are to look for? We know that for every neutral atom, the number of proton and number of electron is the same. But this atom is not neutral. It carries a charge. It carries a charge of -2. And when an atom carries a charge of -2, it means that it has gained electron, because -2 means that we have more negativity than positivity. So it has 2 more negative particles, and the negative particle is electron. So if it was neutral, it's going to have 8 electrons, but 2 minus means that it has gained 2 electrons, which means that number of electrons in this atom is going to be 8 plus 2, and that is equal to 10 electrons. So this atom has 10 electrons. So those are the basic things that you must know about the structure of an atom. Now, what is isotopy and what does it really mean? Isotopy is defined as an existence of 2 or more atoms of an element with the same atomic number. Of course, if they are the same element, they should have the same atomic number. So with the same atomic number, but different mass number. That is how we define isotopy. So the atomic number is the same, but their mass number is different. So they have different mass number. And they are going to have different mass number because of different number of neutrons in their nucleus. So every isotope differ from each other in mass number because they have different number of neutrons. Also, you must know the difference between isotopy and isotopes. Those two terms are related, but they are not the same thing. Isotopy itself is the phenomenon, is the existence. Isotopes, they are the atoms that have the same atomic number but different mass number. Now that we have differentiated isotopy and isotopes, let's look at how we calculate the relative atomic mass of an atom that exhibits isotopy. But before we do that, let me say that if an element exhibits isotopy, each of the isotopes of that element are going to be abundant in different proportion. For instance, for chlorine atom, chlorine has 2 isotopes. It has an isotope that has a mass of 35 and another isotope that has a mass of 37. In nature, the atom or the isotope that has a mass of 35 is about 75% in abundance, while the other one is about 25% in abundance. So chlorine as an element has this isotope to be more abundant. So we must factor in the abundance. Now the formula that I give for calculating the relative atomic mass of an element that exhibits isotopy is relative atomic mass is equal to mass of the first one multiplied by abundance of the first one plus mass of the second multiplied by abundance of the second, then till you add all the abundance of all the isotopes. So if it has just 2 isotopes, it's going to be mass of the first multiplied by abundance of the first plus mass of the second multiplied by abundance of the second. So where M is equal to mass of each isotope and this alpha represents abundance. Let me say emphatically that abundance can be expressed either in percentage or at times it can be represented in fraction. So depending on what the question gives you, that is how you are going to tackle it. Now let's solve this question. Let's use this question to buttress our point on isotopy. This question says that a chlorine occurs as 2 isotopes. So we have 2 isotopes. The first isotope has a mass of 35. It's supposed to be written this way. Then this is the abundance, 75.78%. Then the second isotope has a mass of 37. The abundance is this. So what is the relative atomic mass? If we plug that into our formula, the mass of the first one is 35. So we have 35 multiplied by abundance of the first one is 75.78%. So we have 75.78%. That means over 100 plus mass of the second one is 37. The abundance of the second one is 24.22%. So over 100. This will give 35 multiplied by 75.78 divided 100 is 0.7578 plus 37. 24.22 divided 100 is 0.2422. Now let's plug this in our calculator. So 35 times 0.7578 will give 26.523. 37 times 0.2422 will give 8.9614. So if we add this, we are going to get 35.48, which we can approximate as 35.5. So the relative atomic mass of this chlorine atom will be 35.5. Now let's look at this last question to consolidate our knowledge on isotopy. So the question says that given the mean atomic mass of chloride prepared in the laboratory to be 35.5, so the mean atomic mass is the same thing as relative atomic mass. So relative atomic mass is equal to 35.5. And assuming that chlorine contains two isotopes of mass numbers 35 and 37. So I will take the mass of the first one to be 35 and the mass of the second one to be 37. And the question is, what is the percentage composition of the isotope that has a mass number of 35? So we are looking for the abundance, which is same thing as composition. So we are looking for the percentage abundance of this first one. So I will say F1 is unknown. Now, the formula for calculating relative atomic mass is mass of the first isotope multiplied by abundance of the first plus mass of the second multiplied by abundance of the second. So we stop there because we have two isotopes. Now, the abundance of the first one is not known, so I'm going to call it X. That means you can say that if you plug in, relative atomic mass will be 35.5 equal to mass of the first one is 35 multiplied by abundance is X plus mass of the second one is 37 multiplied by abundance of the second one also is not known. But remember we said that the sum of all the abundance of all the isotopes of an element, if it is expressed in percentage, must equal to 100. So it then means that abundance of the first one plus abundance of the second one must give 100 since we have just two isotopes. So if this one is X and the abundance of the second one is not known and they must equal to 100, it means that abundance of the second one must equal to 100 minus X. So abundance of the second one, I'm going to replace it with 100 minus X. And then they are both expressed in percentage. So it's X percent. So this will be over 100. Then this also will be over 100 since they are expressed in percentage. So it's X percent, X over 100. So they are expressed in percentage. In fact, I'm going to put the percent here so that it will make sense more and will not get it confused. Now let's solve for X. So the first thing we do is combine the denominator because we have the same denominator as 100. We are going to have 35x plus 37 into 100 minus x all over 100 since they have the same denominator. Then we now have 35.5 equal to 35x. Let's fold the bracket plus 3700 minus 37x all over 100. Now let's combine similar terms. We have 35.5 equal 35x minus 37x will give negative 2x. So we have 3700 minus 2x over 100. So let's cross multiply. We have 35.5 times 100 equal to 3700 minus 2x. Now we have 3550 equal 3700 minus 2x. So I will add 2x to both sides and subtract 3,550 from both sides. This will give 2x equal 3,700 minus 3,550. Then if you do the math, we are going to get 2x equal 3,700 minus 3,550 to give 150. So x is going to give 150. So x will give 150 divided 2. 150 divided 2 is 75. So it means that the abundance of the first one, which you call x, is equal to 75%. And that's what we are looking for. The abundance of the first isotope, the isotope that has a mass of 35, which we represented with x%, is equal to 75%. So the correct answer will be option D. And the abundance of the second one, which has a mass of 37, will be 25%. But we are concerned with the abundance of the first one. So the correct answer will be option D.